Okay, so I'm going to go over finding limits from a graph, or graphical analysis of limits. So we've got this function here. It's a pretty weird looking function. It's got a lot of pieces, some asymptotes, a bunch of holes. So we're going to find some limits on this graph. So the first one we're going to find is the limit as x approaches -3 from the left. Okay. So -3 from the left. So we're going to look at where -3 is. -3 is right here where this asymptote is. And so when you approach from the left, remember you want to approach from the left, but you want to get close to -3. So when you're trying to decide where to start, we just want to start somewhere on the graph to the left of -3, but close to -3, and head towards -3. And so you can see this piece of the graph that's directly to the left of -3, the y's are increasing, or they're going to infinity. All right, so now we're going to look at the limit as x approaches -5. All right, so if we want to look at the limit as x approaches -5, let's erase this here. Let's look for where -5 is. So here's -5. Okay. And this says just -5. It doesn't say from the left or from the right. So this means from both sides at the same time, do they meet at the same height? And you can see as you approach -5 from the left, you approach a height of 4. And as you approach -5 from the right, you approach the same height of 4. Remember, it doesn't matter what actually happens at -5. At -5, the function comes down here where this closed dot is. But we don't care what happens at -5. We care what happens as we approach -5, and both sides approach a height of 4. All right, so now we're going to look at the limit as x approaches -1. And again, this is both sides at the same time. We're not coming from the left or from the right. We're coming from both at the same time. So here's -1. All right. So from the left would be here. From the right would be here. Those are the parts of the graph that are closest to -1. I know there's lots of pieces to the left, lots of pieces to the right, but we look at the pieces closest to the value we're approaching, and they both approach the same height of -1. Okay, so now we're going to go back and look at -3 again. So -3, that was the first one we did. We're going to look at it again, but this time we're going to talk about both sides at the same time. Not just from the left or from the right, but both sides at the same time. We already saw from the left that the left side goes to infinity. So now we need to look at the right. The right side goes to -infinity. And not only are those increasing and decreasing infinitely, which means the limit doesn't exist, they also don't match. So the limit here does not exist. Okay. Carrying on here. The next one, we've got the limit as x approaches +2 from the left. So here's +2 from the left, right? So the piece of the graph closest to 2, but to the left of 2 would be this piece. And as this piece gets closer and closer to 2 on the x, it's getting closer and closer to 1 on the y. All right, so now we're approaching 2 from the right. So the piece of the graph that's closest to 2, but to the right of 2, is this piece up here. And as this piece gets closer and closer to 2 on the x, it gets closer and closer to 6 on the y. And because these two did not match, the limit from the left and the limit from the right didn't match, then this next one, the general limit at 2, where we come from both sides at the same time, they didn't meet. There's a break in the graph at 2. So this does not exist. All right. Okay, so the last thing we're going to look at is as we approach positive and negative infinity. And remember, this is, instead of looking at the graph zeroing in on a specific x value, this is looking at what the ends of the graph are doing. Negative infinity is the left end of the graph, positive infinity is the right end. So the left end of the graph, if we look at what the left end of the graph, the end that is headed towards negative infinity on the x, it's leveling out at this horizontal asymptote. The further left you go, the flatter this graph is getting, the more it's bending and approaching that asymptote. And the height of that asymptote is 2. So we would say the limit as you approach negative infinity is 2. Now, as you approach positive infinity, that's the right end of the graph. So if you look at what the right end of the graph is doing, the right end of the graph, it would be this piece down here that's the right side of the graph. It's not approaching that asymptote. That arrow means that it's going to keep going the way it's going, and it's pointed up towards positive infinity. So the right end of the graph is headed to infinity. The left end of the graph is leveling out at 2 at the asymptote, but the right end's going to infinity. Okay, so this is the second example. I'm going to ask you to pause the video for a second here and try to work through these, and then I'm going to post the answers. And if there's any of these that you don't understand, these would be good problems for you to bring to class tomorrow. So pause your video, and when you're done trying the problems, turn it back on, and the answers will be here. Okay, so how'd you do? Check over your answers here. If there's any of them you don't agree with or you don't understand, make a note of it and bring it to class tomorrow or on Tuesday, and we'll go over any questions that you have. But that's basically finding limits from a graph.